Hello, everybody, and welcome to today's Dynamics 365 Tech Talk. Today's topic is Preparing for Finance and Operations Service Protection API Limit. My name is Cora, and I'll be your moderator today. We are broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on the Tech Talks Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions throughout the event, and there will be time at the end for additional Q&A. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Jared Hall, Principal Program Manager. Jared, over to you.
Thank you, Cora. So as Cora mentioned, we're talking about Finance and Operations App Service Protection API limits today. These are API limits that we're implementing for OData and custom service endpoints. And in this session, we'll talk through what the limits are, how they'll, what their purpose are, and what the rollout plan is, and also some mitigation strategies for ways we can work with these API limits and ensure that we're getting the maximum amount of throughput through our API integrations, and really getting quality out of the integrations that we have with the Finance and Operations Apps service. I'm joined today by Rahul Agarwal. He's a Principal Engineering Manager on the project for these Service Protection API limits. And as we go through the session, Rahul will be looking at the Q&A and answering those questions as they come in. So make sure that you ask those questions and keep the conversation going in the Q&A as we go. He'll respond to those, but also we'll make sure there's plenty of time at the end to continue the conversation on questions at the end of the presentation as well. So jumping in. Our service protection API limits, what are they for? We're implementing these service protection limits to ensure consistent availability, reliability, and performance of the Finance and Operations service. The intent is to protect against extraordinary usage of APIs against the service that have the potential to have negative impact against the performance of the service, or even temporarily bring the service down. So on our side, as we manage the Finance and Operations service, we have service engineers that are looking at the performance and managing the availability of the service, and looking at the uptime and service level agreements that we have with that service, and the agreements that we have in guaranteeing the uptime of the service. So as we look at the best ways for us to protect the service and make sure that we can keep those service level agreements, this is one method that we're using to ensure that. We have, over the past year, we've been doing an analysis of the usage of our APIs and seeing that depending on the usage of the APIs, that they have the potential and have brought down individual customers and the service negatively impacting the performance and availability of the service for that customer. So this is another mechanism for us to ensure that uptime and reliability of the service. There are 2 limit types. We have these broken down into the type of resource-based throttling and user-based throttling, user-based protection limits. The first one, resource-based, these are limits that are based on the aggregate usage of the server service resources, the server and the database resources for that environment. So we have specific thresholds set that when those thresholds are breached and we see that that environment is in danger of having a negative impact on performance or availability, in aggregate usage across all API users, across all workloads, affecting the usage of the resources in that environment, at that point we look at throttling API requests against that environment. This allows for throttling prioritization, which we'll talk a little bit about, but this is something that has been available in Finance and Operations environments since PU43. So it's been around for a while, and something that you may be used to and already have planned into your strategies for your API requests. What is new and coming soon is user-based service protection limits. While the resource-based protects against aggregate usage of the environment resources, the user-based protects against individual users or integrations from extraordinary usage that has negative impact against the performance and availability of that environment. So it's like making sure that one user or one integration isn't bringing down the entire environment. And there's 3 limits that we have in place that we'll look at in detail throughout this presentation. But these are coming and in 2022 release wave 2, which is the major release coming this October. So looking at the 2 different limits, just a quick graphic to help us differentiate between the 2 and how they operate. With resource-based API limits, we're looking at multiple users that are making requests against the API of that environment. And as each request comes in, it takes additional server resources or service resources. And as that all adds up, once we get to the point where we're breaching thresholds that threaten the availability of that service, at that point, the next API request that comes in will get a 429 response. Or we'll begin throttling the API requests coming in for usage to slow down the requests coming in so that we have a chance for those server resources to catch up and begin to bring that back down into normal usage. So the question here, though, is if we have resource-based API limits and none of these individual users is really extraordinary usage, it's just the aggregate usage of these resources with the API limits, how do we decide which of these clients to throttle? If 15 new requests come in, how do we decide the order in which they're throttled because of the aggregate usage against those resources? With resource-based API limits, we allow the client or allow the environment to determine the order in which these integrations are throttled. So we have a throttling priority mapping within the application, where you can go into the priority mapping page and select the integrations that you have set up for finance and operations and determine the priority in which they will be limited when that resource-based throttling happens. So we can set the priority for high, medium, or low, and then the throttling manager honors that prioritization when the resources are the resource thresholds are exceeded in that environment. So that's the kind of the operating for those resource-based limitations. When we look at user-based service protection limits, these are the limits against individual users or service principals. So these are API limits that are enforced per user or service principal per web server of that environment, which is the web server would be the AOS node. For each user per web server, we have 3 limits. The first category is the number of requests. Each service principal is limited to 6,000 requests within a 5-minute sliding window. The second is execution time. Each user within that 5-minute sliding window, over the last 5 minutes, you would be limited to 20 minutes of total execution time of all of the requests that are being made against that environment, or the OData endpoints or custom service endpoints of that environment. And then third category is the number of concurrent requests. You're limited to 52 concurrent requests made by that individual service principal against that environment. Something to note on these is that as we came up with these limits, these limits are the result of about a year of analysis against the environment, against all environments across the service. That we've looked at done an analysis to see what are the workloads that the service can handle per web server, and also balance that against what is the current usage of customers against these environments. And it's worth noting that these limits are higher than the typical usage of a customer using finance and operations service. These are so the typical user likely won't be impacted by these limits, but we would want we want customers to be aware of these limits so that you can implement appropriate strategies for if your usage does exceed these limits, which would be that extraordinary usage where an integration or a user begins extraordinary usage against the service that begins to impact the availability and performance of that environment. So how are these going to roll out? These are the user-based API limits that are not yet available. And these will be implemented and available by a feature management switch in finance and operations. So in September of 2022 with PU53, this will be the release before our October major release. In PU53, we will introduce the feature management switch. It will be optional and turned off by default, which will enable customers to begin testing with these service protection limits. You can set it up in a sandbox environment, turn it on, test your integrations and see how it's going to work. You could also turn it on in production environments if you wanted to test directly against your production levels of loads and see how that's going to work. But it's a chance for you to begin seeing how it's going to affect those environments. In October with PU54, this is the 2022 release wave 2 major release. The feature management switch will be turned on by default for all environments. This means that as soon as the update is applied, the API limits will be enforced on in that environment by default. And any integrations would then be would have those service protection limits applied to them within that environment. But with the 2022 release wave 2, it will be optional. So if you are not quite ready, you want to do some additional testing, you have the option within that environment to go into feature management and turn off the switch. And that will be optional for 6 months until the April 2023 release wave 1 major release. At that point, the feature switch will be turned on by default and it will be mandatory. You won't have the option to turn it off at that point. So over the next 11 to 12 months, it gives you the opportunity to do an analysis of these service protection limits, look at the integrations that you have against your environment and see what kind of workloads they have against the limits and do that analysis and put strategies in place to make sure that you won't be exceeding these limits once they're enforced. So how do we handle the API limits with your integrations? Let's start out just quickly looking at how the response happens within an environment when we get throttled. So just looking at, we'll just do some quick Postman requests. In my environment, I have artificially set these limits to be low so we can see what it looks like to get throttled. So if I'm doing a request, let's get some worker tax codes. And when we do our first few requests, everything is fine. But at some point, I'm going to exceed my limits for this user integration, and we get a response back that says it could not be processed at this time. We've exceeded our request. And this is where we get a 429 response back from the server saying too many requests. And in this environment, I have my limit set to 6 so that the next response after that would get this 429 response. The key here is, and actually this message is specific to resource-based throttling. We see the high resource usage utilization. When we get to the September release, these error messages will be more specific to each of the individual API limits, so you know which limit you hit when you get the 429 response. But the key is the retry after interval that's included in the header. This is a server calculated interval in seconds that calculates the amount of time that you need to wait before you can try again without getting that 429 response. So we have the limit here, wait this number of seconds, your standard retry after interval, and that's going to be the key for all of your integrations. Make sure that you have implemented a retry after logic to handle this retry after interval when you get that 429 response. And that's kind of the base level of preparation that needs to happen for these API limits within your integration. So we'd expect that there'd be a handling for a 429 response and then any additional mitigations that need to be put in place to optimize your integrations if it looks like you're going to be exceeding those limits. So looking at how do we handle that 429 response? And one of the things to consider when you're looking at your strategies for how to handle the 429 response is what type of integration you have. And there's three general types of integrations that we look at with finance and operations. The first is an interactive client. Your interactive client is typically one where you would have multiple users signing into that client and authenticating with their own user credentials. And then requests against the API are done within the context of that user. With these interactive clients, you won't commonly hit the API limits because each individual user is going to, it's often difficult for an individual user to breach any of those limits with that interactive client. But it's something that you'd need to consider as in planning your strategies for the limits of this integration type. For example, if there's ways to do batch operations for that user or high workloads for that user, making sure that you're understanding the workloads that are being called by each of those users against the APIs with that integration. Other integration types are when it's an anonymous user signing into an application. I guess an example of this would be something like a reseller portal, where you have external users signing into or opening up the portal, but not necessarily authenticating against the authenticating in the app itself. So you have a single service principal making calls against the API for all users of that portal. And in these cases, it can be more common for you to hit those API limits when it's a single service principal making those calls. So look at the workloads and see what kind of strategies you would need to use to make sure that you're not hitting the limits for that single service principal. And making sure that you have implemented your retry after response and looking at other strategies that we'll talk about later in the session. Another one is data integrations. Many times you'll have data integrations that are doing bulk data operations against the service through those OData or custom service endpoints. And in these scenarios, it's often a single service principal, and you would want to look at something like batching to balance out the workload that's being done against the service as you make those API calls against the service. But making sure that you have balanced the size of those batches so that you're balancing out the various service API limits that you have. So looking at these integration types, let's see how we could handle these in different methods. So for interactive applications, looking at the retry after logic that we're putting into the application, just some general guidelines. If you have an interactive client application, you would typically want to make sure that you're displaying a message that the server is busy to that user. So if that user is making a lot of requests against the service and gets that 429 response back, don't show them that error message from the 429 response. Just give them a message that says the server is busy, and let them know to try that call is being retried, and they just need to wait. Provide the option to cancel that operation though. If they don't want to wait for that retry after logic to kick in and retry that request, give them the option to cancel that operation. But you would want to make sure that you're not allowing the user to perform other operations at the time when we're waiting for that retry after. That we're not continuing to overload the service by sending additional calls into the service while waiting for that retry after interval to pass. For non-interactive applications, just making sure that you have that retry after interval programmed into the application. So a quick example of that we have in our documentation to show how that works. If you're programming in C#, you would get the status code. If that status code is a 429, set your default to 30 seconds, but then go look for the retry after interval in the header. Get the retry after and wait for that amount of time and then retry the request. So let's look at each of the requests in a little bit more detail. So the limit types. So the first one is number of requests, which is 6,000 over the time window of 300 seconds. And as we discussed, this one can be difficult to hit for a single user, but it's possible in those interactive clients. An example would be if your client allows you to do multi-select operations with a list of data. So if for example, you have a list of records and you can do multi-select that allows you to select hundreds of records at a time and then select a single action that for each of those multi-selected records makes an API call into the service. And if that happens repeatedly over that 5-minute time window, then you do have the possibility of hitting that limit of 6,000 requests over the 300-second time window. So in this scenario, one of the strategies we'd recommend is either limit the number of records that you can select within a list. So you're limiting the number of operations that each individual user can perform when doing calls against the service, but also combine those selected operations into a batch. With Finance and Operations OData, you have the option to select put up to 5,000 records into a batch, but you would want to balance that out. So that's one strategy, is looking at including those multi-select operations into a single batch, so one request can be made, but balancing out the size of that batch so that you're not hitting the next limits, which could be execution time. If we're looking at execution time, this is if you're sending concurrent requests for a single service principal. In this example, I guess we're showing in this animation here that we have 5 requests. If each of these concurrent requests or parallel requests takes 4 or more minutes of execution time against the server, that will add up to 20 minutes of execution time over the 5-minute interval. And when you make that request and we hit that 20 minutes, the next request that comes in from that service principal will receive a 429 response. So to make sure that we are not getting that 429 response, we're not hitting that 20-minute cumulative execution time limit, divide your operations into smaller batches. You can use multiple service principals if you're doing a data integration, but looking at those ways where we can shrink the size of those batches, so we're reducing the execution time for each of those individual requests and balancing that out against the total number of requests that can be made. The next limit is concurrent requests, and this is a good strategy to use in maximizing throughput, as well as making sure that we stay under the API limits. With client applications, we're not limited to sending requests individually in succession. The client can apply parallel programming patterns or various methods to send multiple requests simultaneously. Now, if the limit on the number of concurrent requests is exceeded, the error is returned together with the API response. So although you can send concurrent requests as this can be a key part of your strategy for maximizing throughput, but we don't recommend that you overuse this approach. When you're programming in .NET using parallel programming, the default degree of parallelism depends on the number of CPU cores on the server that's running your code, and this number shouldn't exceed 52. So when you're setting that the max degree of parallelism, make sure that that number isn't greater than 52. And staying under 52 will keep you under that concurrent limit of the 52 concurrent requests. All right, so we talked a little bit in the previous section about balance, and this next section, as we talk about maximizing throughput, we have some general recommendations for strategies that you can use for maximizing API throughput. And we want to emphasize that these are general recommendations, that as we look at this from a service perspective, looking at all the possible integrations that all customers can have against the service for all API endpoints, there isn't a best strategy that we can recommend for that applies to a customer's situation. Everybody's situation is different. Every integration has a different type. It's using different endpoints. It's using different workloads. It's using different number of users. It's using different number of batch sizes. So these are all general recommendations that should be applied. And as you are planning your strategy for maximizing throughput, take these into consideration, but make sure that you're balancing them out to meet your specific needs. It's not something that we'd be able to give you direct recommendations on how to apply these strategies in your environment. But we do want to make sure that these are the general ideas for these strategies are recommended so that you can look at them and take them into consideration when you're working on your strategies for maximizing throughput and managing those service protection API limits. So the first one is monitoring your API throttling. That's one of the first questions we get when we talk about API limits is how do I know when I've exceeded the limits? And we have a report in Lifecycle Services and LCS that lets you see that information. If you go into Lifecycle Services and look at your environment, go into environment monitoring and you have a link for a requests throttled report that will show you the list of all of the requests against the service that have been throttled and received that 429 response. And within your start date range and time range. So this will show you what the request endpoint was, what the priority was, who the user was. So it gives you all that general information, a lot of rich detail, so you can narrow down what the issue is and why that request actually got throttled. So this would be the first step. When you're working on discovering your strategy, go look at reporting to see what are my requests that have been throttled, and then begin the strategy for determining what the workload is, what the batch size is, what the batch size should be, what kind of other strategies need to be implemented to bring down requests for the information that you're seeing. The next report, the next question that we get is, how do I know when I'm about to be throttled? What's my current usage? Even if I'm not getting 429 responses, I want to see what kind of throughput or what kind of workload my integrations and service principals are sending against the service, so I can plan for it and know if I'm about to hit any of these limits. So we do have planned to release a report in Lifecycle Service. It's not available today, but it will be available to show that information, to show you for each service principal or integration against a service. You'll be able to get information on what the current API usage is for that integration, so you can start planning your strategies around it, even if it hasn't yet been throttled. So these are general recommendations as well. Starting with the first one, let the server tell you when to retry the request. This is what we talked about earlier, is looking at the retry after interval provided by the server. We have an algorithm on the server that looks at the throttling limits on that environment, looks at the workload against the environment, and calculates when is this integration going to be able to make the retry that request successfully without receiving a 429 response again. So making sure that you're looking at that retry interval and selecting that instead of just guessing when that time is going to be and continually getting throttled, that'll be your best strategy for making sure that you're maximizing that throughput. Next is looking at using multiple threads. For those individual operations, if your integration has a lot of small, quick calls against APIs, increasing the number of threads may help you achieve that optimum throughput, because we're able to make those short, quick APIs, a lot of them together across multiple threads, helps you maximize that throughput for that integration. Next one is distributing workloads across multiple service principals. Something to keep in mind is that the user-based service protection limits are per user per web server, or per service principal per web server. So distributing those workloads across multiple service principals enables you to stay below those API limits, so that it's not a single integration or a single service principal that's bringing down the service, but distributing that workload across multiple service principals. You can use this with bulk data operations, but also the strong recommendation is don't use a single service principal for all of your integrations or for multiple integrations. Make sure that each integration that you're using has its own service principal, so that we can stay below that API limit. Next one is avoiding large batches. Remembering that we're per user per web server, but using those multiple service principals for the bulk data operations, but limiting the limit for those batch operations is 5,000 per batch, but we don't want to continually use those 5,000s or use that as the default. Start small with those batches and gradually build up the size of that batch until you have optimized your throughput for that batch size. The limit would be 5,000, but please don't use that as the default. Start small and increase that until you see that maximum throughput coming through for that integration. Another recommendation is, well, something to consider, not necessarily a recommendation because it depends on your integration, is removing the affinity cookie. Azure services, when you're using an app that's registered in Azure, by default, you'll get a service affinity cookie that's returned with an API response. And that enables you to reuse the cached data. So if you have multiple requests coming from a single client, by default, that affinity cookie will make it so that all of the subsequent requests will continue to go against the same web server. So if you have 24 web servers in your environment, this cookie will make sure that your client continues to use the same single web server over and over and over. And for some integrations, depending on your integration type, that may be ideal. That might be optimum because then you can reuse the cached data that's sitting on that web server for that integration. However, if you're doing something like bulk data integrations and you don't necessarily need to reuse cached data, you may want to remove that affinity cookie so you can spread the load across the web servers that are available for that environment. So rather than having all of the requests for that integration going to a single web server, you can spread it across the multiple web servers because the limits are per user or per service principal per web server. So that may be a strategy that you want to consider is using this code just for that integration, remove that cookie so that the workload is spread across the servers. And then last one, optimize your connection. There are strategies for when you're coding in .NET to be able to optimize the connection that you have against those OData endpoints. And we have some more notes on this in our documentation on how to use these for optimizing that connection. So these are just general guidelines that we recommend that you look at when you're considering the service protection API limits and coding your integrations against those APIs. There are ways that we can optimize the throughput, maximize the throughput, and make sure that we're getting best usage out of the API calls that we're making against the service. So the API limits themselves are to ensure that we're maximizing performance and availability of the environment, and this is helping to encourage the best use of those APIs. One last note is that there are some temporary exemptions from the API limits for first-party services and Microsoft services. This list here, like retail service, server API, Office integration, dual write, the virtual entity connector for Power Platform, these integrations that use OData are temporarily exempt, while Microsoft services plan implementation of the 429 response within their services. But if you have integrations against these, the best practice is to still consider the 429 response that you may get in handling these handling the responses that come from these services, so that you're prepared when the limitations are applied to these API clients. So look at the plan is for each of these individual first-party services for Microsoft services to take that up. So we want to make sure that we're calling out that these are temporary exemptions and that over time we will make announcements within our documentation and also send out announcements to administrators through email when the exemptions will be lifted for these first-party services. And with that, we have some additional resources you can take a look at. Want to note that if you look at documentation, aka.ms/FinOps API throttling, the documentation that we have written up includes all of the information that we talked about in this session today. And you can get some more detail there, but we encourage you to go look through it and take a look through the documentation, read up on the resources that are available and guidance that we have for handling the API limits, and give us feedback. Let us know what you think. We've also set up an email account so that if you do have questions specific to API throttling, send us an email and let us know so we can answer those questions. Note that we can't give specific guidance on what you should do for your integrations, but we can give you general guidance and see the best way for us to work with those API limits in your integration situation. Also, we'll have office hours coming up. Those will be available to the to public, both internal and external customers who have questions, and we'll make that announcement coming soon. We have the plan to come up starting in a couple months once we get into the full swing of implementation of the API limits, so that customers and partners can come to those office hours and ask those questions around how to best implement strategies around the API limits and throttling. So that's we'll close on the presentation portion of that and open it up for questions and see what kind of questions have come in. Rahul, are there questions that we have in the list to go through?
Yeah, so I've been publishing the questions that have been coming in and answering in the chat. There are still a few that we can go through. And so like, for example, there was just one question right now which asked about the WHS application will no longer be exempt from throttling in future. I think the answer is yes. Once the WHS application team has added the retry handling as well as the best practices that that Jared just covered, at that point in time, we will remove that from the exemption. But before that, there's going to be communication through our documentation so that you can prepare for it and test it before we remove that exemption. And I think there's another similar question I'm just going to publish. It basically, so once the temporary exemptions from the API limits for first-party Microsoft services like DIXF, Data Integrator, etc., will these services just handle the retry after logic on their own, or will we as customers need to do something differently? So I think the straightforward answer is, as I said, these services will add retry handling within these applications and integrations, and as well as also follow the same best practices that we have recommended. And then, so we don't expect anything that customers will have to kind of guard against these services. And that was the last one.
All right. Were there any key questions in the Q&A that you wanted to call out specifically to provide a little more detail?
Yeah, I think there was one question about like, what if this throttling gets in the way of actual business requirements? Is the recommendation to switch ERP systems, or is there a way to expand the limits? So I think this is an interesting question, and I want to address kind of where you're coming from. I understand that you may be thinking that this is going to affect the actual business scenario, but I want to ensure that the way we have designed this feature, and the reason we have designed this feature is to ensure business kind of continuity, in spite of like overuse and overutilization of resources, as well as by a single user. Unintentionally, it may happen that it can bring down the system, actually kind of affecting your business. So in the absence of these service protection limits, you are exposed to those kind of outages. And what we have done over the last 1 year, is we have done extensive analysis with the data that we have been getting from our production environments, and that, considering those data points, is where we have kind of arrived at these numbers, so that we can support the workloads that we currently have from our customers. Now, having said that, we have also the best practices that we have shared in our documentation, and Jared kind of walked through them. These are the best practices. If we follow these best practices and the data analysis that we have done, we are confident that there isn't going to be. In fact, there's a very small percentage of customers, not even percentage, like it's a handful of customers who are beyond these limits as per the current thresholds that we have shared when looking at the last full 1 year. And in addition to that, what we are doing is, in addition to the flexibility that we have right now, like Jared mentioned, that you have time to adjust to these kind of changes coming in, we are also going to be proactively reaching out to those individual customers who we think are closer to these limits, and they might run into these thresholds or cross these thresholds at some point in time, so that we can warn them and we can make them aware about these changes coming in and give them opportunity as well as collaborate with them to make changes in their integration so that they don't kind of run into this problem which may affect their business.
Yeah, I think that's a really good point, Rahul. And we want to emphasize that these service protection API limits are to protect against extraordinary usage. We want to highlight that a few times in the documentation, that it is extraordinary usage above and beyond your typical use that is going to get throttled. And it is just a handful of customers that are currently over these limits. So if you're concerned about these limits and you're looking at them thinking this is going to affect my business, our first recommendation is please go take a look at the integrations that you have and analyze to see, is there anything am I currently over these limits, one, and if I am over these limits, is there anything I can do using these strategies to bring my integrations down below those limits? Because there are a few there that are very effective in helping you mitigate those API limits. But if you've done everything you can and it looks like there's just nothing that you can do to stay under these, which you would be an extraordinarily rare situation to be in that situation. But if that does happen, please email us. We have the email address there, the FinOps API throttling, and we can have a discussion on what the best strategy is. All right, looks like we don't have any other questions coming in. So we still have 19 minutes left in the session. So we've presented everything we need to on just talking about the service API limits, the purpose of what we have for those API limits, and making sure that we can ensure the reliability and performance of the service, and making sure that we have and availability as well, making sure that we have uptime that we can guarantee with our service level agreements in those environments. This is an important workload for us on the service engineering side to make sure that the service is available for customers using it. And this is just one strategy for those customers that are having negative impacts with those API usage, for the small handful that are, and potentially others that could. So even if you are below those limits, we recommend that you take a look at these strategies. Make sure that you've implemented responses for 420 or handling for 429 responses from APIs, and looked at strategies to maximize the throughput of your APIs so that you're getting the best usage possible out of the API integrations that you have against the environment. Look at the things that we've talked about, and if you do have additional questions, please reach out to us. We want to work with you to make sure that you're as successful as possible with the service. We're doing this to make sure that customers have the best possible experience with finance and operations service. So with that, Cora, we'll turn it back to you.
Thank you. I've posted a link to a short survey in the Q&A panel. We'd like your feedback on today's session and to hear what you'd like to see in future events. Thank you for your participation. As a reminder, the recording of today's session will be available on the Tech Talks Community Dynamics page within 5 business days. I'd like to extend a big thank you to our presenter and audience for joining us today.